We start the second quarter with the section on bonding and nomenclature. This section is covered in chapters 6 and 15, which includes ionic bonds and compounds, and chapter 16, which includes covalent bonds. Those are our two basic types of bonding. In ionic bonds, electrons are transferred between atoms. It typically involves a metal that loses electrons to become a positive ion, and a nonmetal which gains electrons to become a negative ion, and then these oppositely charged ions attract. The second type of bonding is covalent bonding, where electrons are shared between nonmetal atoms, and what we typically do is draw Lewis dot structures to show how the atoms are bonded together. So here are some examples of some common molecules that exhibit covalent bonding, the names and formulas of these various molecules, and then their Lewis dot structures that show how they need to share electrons so that each atom is satisfied, typically by having 8 electrons around it to satisfy what we call the octet rule. The only exception to this really is hydrogen, which is a small enough atom that it only needs to be surrounded by 2 electrons in order for it to be satisfied. Finally, number 39, this actually belongs in the section on bonding and nomenclature rather than the section that it's placed in. This is what we devoted lots of time to: memorizing radicals, knowing the charges of ions, using the periodic table, using our crisscross method to write proper formulas for these ionic compounds. So a couple of examples to look at here. If we're going to combine the magnesium ion and the chloride ion, we crisscross the charges and we get MgCl2, and its name is magnesium chloride. Now in some cases we put an ion together, like the magnesium ion, with one of the radicals that we studied and memorized, and in this case when we crisscross the charges we get Mg3PO4 and we need to put parentheses around the phosphate ion to separate the subscript of phosphate from the subscript 2 used to balance the charges. Another one to look at here, magnesium ions combining with carbonate ions. We get MgCO3. Since they each have the same charge, a positive 2 and a negative 2 charge, those charges balance, so we really just need one of each ion in order for the charges to balance one another. And then one final one to look at, if we combine the Fe+3 ion and the oxalate ion, again we get the crisscross method, Fe2 and then C2O4 3. We need the parentheses around the oxalate, but also since iron is a transition metal, the only way really that we can know which charge ion we're talking about is by using the stock naming system, which requires some Roman numerals in the name to tell us which iron it is. In this case it's iron 3 oxalate to produce this formula.